Hello guys and welcome to Magnification channel. So this is going to be our next project video in which we are going to build our optics calculator app. And without wasting any time, let's jump into the coding part. So as you can see, we are going to make this optics calculator app, which is going to calculate different optical measures such as calculation of object distance, image distance, magnification, and also the refractive index. And this can be calculated by using the implementation of the following formulas. That means Nernst formula, magnification formula, and Snell's law. Basically, Snell's law is nothing but just uh, it states that the refractive index of any material is the ratio of sines of their angle of incidence and angle of refraction in measured in radians. So that's what we are going to implement. Now for that we need an extra library which is basically math library because we have to calculate the sines. So let's start by importing the math library here. Next we need to basically define different type of function. So let's first define the lens formula, and the lens formula is going to be something like this. Lens formula. So lens formula is nothing but 1 divided by f equal to 1 divided by v minus 1 divided by u. So this is what the lens formula is. Now, what if we want to create a function? Basically, let's lens formula. So as you can see, we have our lens formula ready. Now we are going to create actually this lens formula in such a way that it is going to say, so it is going to just ask for this function is going to handle all the console as well as calculation part for lens formula. So I hope this is clear, the statement that I have written, that this function also going to incorporate everything, basically the console part and as well as the for calculation part. So first of all, whenever we are going to implement lens formula, so there is one thing that we must keep in mind. So every time we are just going to calculate one entity such as focal length f, or maybe we are going to calculate the image distance or maybe the object distance. So to calculate one, we must have the other two with us. So the same thing, with the same thing, we are just going to create a menu here. So I will not even say invest time in typing all those things. I'm just going to copy and paste that. So as you can see, there are going to be three features, basically one, two, and three options, in which we are going to calculate different entities. First is focal length. Basically, if you want to select the calculation method where we want to calculate focal length, we just have to type 1 here. And in the similar way, we can calculate different things. Now, we are going to take this choice here. Choice is equal to input, or maybe int input. And in the int input, we are going to say enter your choice. So this is what we are going to ask from user, that what type of calculation that user wants to do. So if lens choice, sorry, lens choice equal to 1, then do one thing. It is going to ask user for u and v and calculate f, and then print what is going to be our f. Now let's ask u from user. That means it is going to be a floating point number, and floating point and input. Oh, sorry, we have just executed that. Okay, let's delete that. I don't know what actually happens. Let's delete. Okay. We have created this function u. In the similar way, we are going to actually ask for the user input for v. Then we are going to calculate for f. Now f is going to be calculated by 1 divided by and minus. So this is going to be something like 1 divided by v minus 1 divided by f, sorry, u, and whole to, is going to be the denominator of 1. So this will going to be our formula for calculating this f. Now this empty function is actually making no sense here, so that's why I'm going to put a prompt here, which is going to calculate, basically ask user for the specific values that we want to print here. So let me copy and paste that. So object distance u, as you can see, and we can use u for virtual objects, and similar way we can ask for v, and at last what we are going to do is what we are going to print something like focal length. Let's say f is going to be centimeter. So this is what we can print, and in the similar way we can just copy this whole, paste it here, and rather than a leaf, sorry, we are going to put a leaf here and change the lens formula choice by 2. And now for the, you can say, second part, we are going to calculate the object distance. So that means this time we are going to need to take input for f. Only we are going to change this u to f everywhere. Sorry. And this becomes formula to calculate u, which is object distance. And this object distance is also going to be measured in centimeter. And the prompt for taking f is going to be changed, of course. And this is going to be like something like this. So that means if you are using concave lens, that means of course you know what we are going to enter. So if you want to calculate something for concave lens, you can just put -1 there or negative value, and at last we are going to get our value of u. In the similar format, we can do is we can just simply copy this source, paste it here in the next line, change the choice to 3, change u to v, object to image, and in a similar way, change everything in the function and image to object and u to v. So this is what going to be our calculation for u. Sorry, sign problem. We have to first change the and let me recheck the formulas. Okay, everything is looking good. Now, for the else situation, there might be a situation where user, you can say by default, sorry, by mistake or intentionally type something wrong, and at that time we want to print an error message, or you can say warning, which state invalid choice, and then retry. So this is something that we can print to the console. Basically, we have written our lens formula. Now to test this lens formula, what we can do is we can just simply call this lens formula here and run this whole program. So of course, it is going to ask for our choice. Let's say I want to calculate the focal length, and object distance may be in 30 and image distance may be at 5. So this is going to be a focal length. Basically 6 centimeter is going to be a focal length, and that's how this program is going to be run. Now let's close the terminal and let's write our next function. Now this function is going to be for calculation of magnification, and the magnification can be calculated by magnification. Sorry, and can be calculated by dividing object image distance by object distance, and this can be simply wrapped into a function of magnification. Now this magnification is going to take 2 arguments or maybe none. So for now, let's pass that and complete this lens formula. Why I am saying complete, we are going to type in here, let's say float value. Okay. So magnification. Magnification is also going to return us some float value. Now for the magnification part, we can say that this function is going to calculate ask user for u and v, then calculate magnification. Now this function is going to take ask user for the different, you can say, inputs, and it is going to ask. So basically, we just need the same inputs as this, So we can just simply take it from here and we can just paste them here. So after taking the input from the user, we can just simply say m is equal to v divided by u, and that's all. And at last, we are going to print magnification, or to be precise, linear magnification m is equal to maybe a small m. So this becomes our magnification function. Now next we should calculate the refractive index, and let me just put to the comment here to save the time. So as you can see, we are now going to calculate our refractive index function, or also the formula for refractive index. So we are first going to define refractive index, and in a similar way as u and we are just going to print real. I think I forgot to put a magnification. Now at last we are going to calculate refractive index using Snell's law. So first let's put this here, and this refractive index is also going to be a floating value, and the same line can be said for this. But let's just change u and v to I and r. Basically, I is angle of incidence and r is angle of refraction. Calculates refractive index n. Now, so as you know that we want to calculate the angle of you can say, sorry, the refractive index, we must take two input, which are going to be these, basically angle of incidence and angle of refraction. So these are going to be our float value course. So these become our angle of incidence and angle of reflection. Now we are going to calculate the radian angle. Basically, we are taking input as a degree and then converted them into the radians. And at last, we are just going to put the formula for Snell's law, which is as simple as that. That means n here represent the refractive index, and then again terminal opens by the way. I don't know how what keys are pressing by me. So then first it will going to calculate the sine of angle of incidence, then sine of angle of reflection, take the ratio, and that ratio will lead to calculation of refractive index. So now we have calculated everything. Now it's time to write our main loop here, basically, and this is going to be a while loop. So while true, and first we need to print an menu Sorry if I'm copy pasting too much because it's just redundant information for us. Now we are going to take input from the user, or it's his choice or it is her choice that what for what feature he wants to use this optics calculator, and then there is going to be an if else block that is simply going to uh, map the user input to the accurate formula, which is by if the choice made by user is one, that means user want to use the lens formula, then lens formula function is getting called, and then in a similar way, then we call magnification or refractive index respectively. Now there is also a functionality if user want to exit midway. Uh, this is going to break the loop, basically the infinite loop. And also, if there is a other entry other than this 1, 2, 3, 4, it's going to print a message in the console and says invalid choice, please retry. So if I try to execute this code, so as you can see, it's asking for us, let's say, if you want to use this magnification formula, and it's asking for us the user, sorry, let's say 40 object distance, and image distance is 3, then the linear magnification is 0.75. That means the image is getting getting created at much closer to the lens. Of course, we can't just take input from the user for the height. This is the linear magnification. Now, checking the third function, which is a refractive index. Let's say angle of incidence is 30 degree and angle of refraction is 45 degree. So our refractive index becomes 0.70. And if we want to exit this loop, we can essentially type 4 and we get to exit the loop. So this is the final, you can say, functionality of this optics calculator app. And that's with this, we actually wrap up our Python project for optics calculator. Now, if there is anything you feel that I have quickly covered that, or my speed was really fast, so maybe that can be explained in the next video if you said so in the comments, or maybe any other dedicated video for that. So if there is any suggestion, please do share in the comments. So thank you all, and let's meet in our next video.